So let's continue with double stub matching. So here what is the difference is diagram is given to us. So for a double stub tuna shown below, find shortest values of LS1 and LS2 to match the load. So these are the two steps. Characteristic impedance is 50 ohms for everything, and this is LS1, this is LS2. We have to find out. And remember, we have to find the shortest values. So we have already seen in single stub matching we have two solutions. Same way we have for double stub matching. I suppose I forgot to mention in the last lecture. So we have the two solutions again, because G equal to one circle, when we move clockwise we can again intersect at 2 points. So we have two solutions. So from that, where we get the shortest length, that we have to take as the answer, because it is given in the question. So how we go about this? We first draw the diagram, we generate the concept, and then we solve, right? So since the stubs are in parallel, here it is Z0 normalized becomes 1 plus J0. Since the stubs are in parallel, we use G plus JB, right? And let me draw the two stubs first. So this is first stub, this is the second stub. So I'll start from here only. So this is, we had taken as point A, this was point B, this was point C, right? And then from here to here our length was, this was L1, this was L2. So L1 we had said we can take any arbitrary distance, but here we cannot take, as it is given as lambda by 8. So we have to take L1 equal to lambda by 8 only, which is 1.25 lambda. So what we do first, we go from G plus JB while bar to point, we travel a distance L1 along the transmission lines, means on which circle we move? We move on VSWR circle to reach a point B minus. So this G plus JB becomes what? G1 plus JB, what we have taken? 1, I suppose, right? Then what we do? Then we say this distance is given to us, so it is given as lambda by 8, right? So we construct a rotated G equal to 1 circle, right? So from B minus we have to go to B plus. Then we had seen stub changes only the reactive part, so this is G1, so this will also be G1, and this becomes something JP prime, right? So we have got B plus. So from B plus we travel a distance lambda by 8, again away from the load, so we move clockwise to arrive at C minus. So C minus by what will be there? Both will change. Why? Because we have moved along the VSWR circle. So this will be G2 plus JB2. Now this is, sorry, so both will change and we move such that this is 1 admittance, 1 plus JB2, because we have to match with 1 plus J0. So this is 1 plus JB2, adding what we will get? 1 plus J0 minus JB2. So this is minus JB2, right? And yeah, and now we have to find this reactance. What is this reactance? What we do? What we did here, 1 plus JB2 minus JB2 is 1 plus J0. So in the same way we will do G1 plus JB1 minus JX equal to G1 plus JB prime, G1 plus JB prime. So you solve this, G1 gets cancelled, so you get JX equal to J times B1 minus B prime. So therefore Jx equal to minus J times B prime minus B1. Am I correct? Yes. So this is what we have, minus J times B prime minus B1. So let's do this. So what is ZL? 100 plus J50. So what will be ZL bar? ZL by Z0. So therefore ZL bar equal to ZL is 100 plus J50, 100 plus 50 I divided by 50. So 2 plus J, again no unit. Just a minute, I think I made a mistake. Yeah, we require minus Jx, right? So since Jx is this, therefore minus Jx is this minus. So it is minus J times B1 minus B prime. This we have to do. So what were we doing? Yeah, ZL bar. So we have to plot on the Smith chart. So what is the first step to plot? ZL bar. So ZL bar is 2 plus J. So it will be in the upper part of the Smith chart. 2 is this and J is this. So this is the point. So this is point A. Either you can write point A or you can write ZL bar. Again, we write YL bar as point A, same mistake as the last video. Then what we do, we draw a VSWR circle corresponding to this point. So let's draw a VSWR circle. I'll draw all the circles with green pen. So this is what VSWR circle corresponding to ZL bar. So then we take the diametrically opposite point to the origin at the center of the Smith chart. So this is point A, right? So next what we have to do, we have got YL bar. So from here we have to move a distance L1. L1 is given as lambda by 8. So I have to move lambda by 8 away from the load, means towards the generator. So again, towards the generator means clockwise, it is written here. And we will reach point B minus. So what will change? G will become G1, B will become B1. So impedance as well as that is the admittance will change because we are moving on VSWR circle. So let's use a green pen. We have to move how much distance from point A? Lambda by 8. So 1 by 8 is 0.125. Right? So now let's extend this line. So it is intersecting here at 0.462. So 0.462. And here it is what? 0.5. So I'll subtract it. So I'll get minus 0.038. And how much I have to go? So I have already traveled 0.038. Right? So take negative of this. So minus answer. So 0.038 minus how much is remaining? 0.125. So 0.087. So here I have to move. Fine. So which pen I was using? So that point is B minus. Right? So this is the point. If you have not understood how I calculated this, what you have to remember, the Smith chart is of distance 0.5 lambda. So from here to here I go, it is showing me 0 lambda, so which is 0.5. So subtract this distance, you will get some value. So out of 0.125 we have already traveled this distance, right? So that difference is remaining this. So for that you subtract 0.125 from this, ignore the negative sign. So this is what? B minus, right? Next what we have to do, again refer this. So from B minus we have to go to B plus, right? So for that what we require? Rotated G equal to 1 circle, and for that you check it is lambda by 8 or 3 lambda by 8. Lambda by 8 corresponds to 90 degree. 3 lambda by 8 means 3 times 90 degree, which is 270 degree. So if the distance is 3 lambda by 8, the circle will come here. If it is lambda by 8, circle will come here. So let's draw that. Actually first only you should draw this circle. I again forgot. So take a distance more than half. First you can draw a vertical line which is exactly perpendicular. Take more than half distance of the G equal to 1 circle. Plot on both sides. in here, and then draw a line to the 2 points which you get. So it intersects the perpendicular line, that is the center of the rotated circle. This is the circle. Again, I'll draw it with green pen. Fine. So what we have to do? Now we are at B minus. So from B minus we have to go to B plus. So B minus, what is the admittance? G1 plus JB1. B plus, what is the admittance? G1 plus JB prime. So if you observe, since stub is there in between, the reactance is changing, or strictly speaking susceptibility is changing, and the admittance is same. So you have to keep the admittance same. So where is the admittance circle? Because remember, this is admittance Smith chart now. That is, we are seeing it like this, 180-degree rotated. So what we do, we move on the constant conductance circle. So again, if you have doubts, G equal to 1 is this constant conductance circle. So for this point, this will be the constant conductance circle. And what we have to remember, we have to take the shortest distance. So let's see where we intersect. If we go like this, we intersect here on the G equal to 1 circle. If we go like this, we intersect somewhere over here. So you have to travel a larger distance here. So this is the shortest distance. Since the question has asked shortest distance, so let's take this one. So from this point, you have to go like this. So we come here at B plus, right? We'll find the susceptances later. We'll first draw all the circles. So we are at B plus. Now what we have to do? From B plus we have to go to C minus, and we know that C minus will automatically be 0.125 lambda. Sorry, we have to travel a distance lambda by 8, which is 0.125 lambda, and C minus will automatically get a conductance of 1. Sorry, admittance of 1. So for that we require the VSWR circle for corresponding to B plus. Right. So first draw the VSWR circle. So this is the VSWR circle corresponding to point B plus. So from B plus distance, we have to move a distance of 0.125 lambda away from the load, that is towards the generator, so clockwise. So this is 0.476. plus 0.125. Wait, I had made a mistake. It should not be 0.476. It is 0.036. 0.036 plus 0.125. So 0.161. 0.161. Fine. If you want, I'll draw this with pen. I'll use a blue pen to show these lines. Sorry, brown pen. So we are coming at this point. So if you observe, we are exactly at the G equal to 1 circle only. Right? So our design is correct. Fine. So next, what is the thing? So we have arrived at C minus. So add a negative reactance of these reactants. We'll get minus JB2 and corresponding length. Similarly, use B1 minus B prime. Right? So let's do that now. So we are done with all the plottings. So we have to find the length LS1, LS2. L1 is already given as lambda by 8. So let's do minus JB2 thing for LS2 because it is simple. So 1 plus JB2 for C minus, which is C minus. This is C minus. This is ZL bar, you can write. Right? So C minus, it is 1 plus J1 exactly for me. So minus J1. Right? And it is which stubs are given? Short circuit stub. Remember again, this is a admittance Smith chart. So this is our short circuit. So what we do? We assume short circuit as the load and we move away from the load. That is towards the generator. From short circuit point. So from short circuit point we'll move towards the generator. Till what point? So 0.41 lambda. We should obviously not get 0.41 lambda because we are doing shortest stubs. That is shortest values. Right? So obviously we have made a mistake. What mistake we have made? This is 1 plus J1, right? So we require a negative susceptance of 1 plus J1. 1 plus JB2 ke liye what we require? Minus JB2. So for plus J1 we require minus J1. So J1 is here for negative side. So take this one. So from short circuit you are moving away from the load, that is towards generator. So move like this. So this is our distance for second, right? So LS2. So this is 0.375 and this is 0.25. So 0.375 minus 0.25. So 0.125 lambda we are given. So this is 0.125 lambda. Right? And then what we do? Minus J times B1 minus B prime. So what is B1 corresponding to B minus? So B1 is around 0.52. 0.52. B plus is 0.18. So minus 0.18. Right? And negative of this because it is minus. Right? So minus J 0.34. Right? So minus J 0.34. So minus J 0.34 is here. So this distance is LS1. So 0.34 minus 0.25. So 0.09. So this is 0.09 lambda. So these are your answers. So make sure you draw this again. This is your final diagram. So you have to draw this again. So it carries at least 1 or 2 marks to redraw the final answer. Because first the examiner is going to see this diagram only. And again, as I always tell, write the question number here. Because you will attach the thread here. Okay. So I have not taken this sum from Prozer. I have taken this sum from the book Radio Frequency and Microwave Communication Circuits by Devendra Mishra. You can refer this sum from there. I think there are small differences in the sum. So you just try it again yourself and just check whether you are getting the same values as me or as from the book. Okay. So next time we'll start with the different matching technique. So make sure you solve this because it is very important. As I told you, it carries 10 marks and last time we got single stub and double stub matching both in the exam.